Hi, welcome to my channel Mathemagics with Mohsin Raza, and we will see the magics of mathematics. And in this video, we are going to talk about set and functions. So usually, its perception about the set and function is that whenever someone think about the set, then he think like there would be some numbers, there would be some like natural numbers, real numbers, and rational numbers. Not more than that we could think of. Like, but in this video, we will see what actually is the set and what actually is the function. Is it the function seems like a dream of the mathematician? No, that's not true. That mathematics doesn't develop like as a dream of mathematician that he get up on the early morning and say, "Oh, I have seen this dream and this is that thing." So let's see what actually is the set, and so let's have a magic together. And if you haven't subscribed the channel, so please subscribe the channel, and for more interesting magics of mathematics. So let's see what actually is the set. So set is we are surrounded by a lot of things that are can be written, collected in collections. So sets actually is a collection of objects, but that is collection of object is a particular type that would be a well defined and distinct. So this is really interesting to know that what actually means by well defined. Okay, so well defined means a collection is well defined if you could tell about, let's say, this collection. I say this is a C, that is just the name of that collection. And if I could tell that something, let's say that something is apple. Okay, so if I could say that apple belongs to this collection or not, if I can clearly state about this thing that this apple is in it or is not in it, so then that collection will be well defined. Okay, so and distinct, that is a different one, that all objects are different. So different is very interesting in this way that what actually that this is a synonym of distinct, but that makes things like there are three apples in a collection. Okay, so first of all, three apples, that then every apple is distinct from another. Like every human being is a distinct from another human being, so the same way that every apple will be distinct from the other one. So this, let's say this is a first apple, this is a second apple, and this is a third apple, so this is distinct. Okay, and how that is well defined, let's say if someone asks you that this is a your collection. Okay, and someone asks you that either mangoes are here or not, so you can clearly state that no, mangoes are not in this collection. So that makes it well defined. So here, I hope so you have understood that what actually is the well defined and distinct means. So here I have given a very interesting examples of some collections, and you have to judge that which one is the well defined or not. Okay, and even you can tell about the which one is the set or not. So here that is a collection of mangoes. So like right, this is well defined for me because even for everyone, right? So because you can say that everything like everything that onion, apple, banana, you can say this is not there. And whenever someone asks you that that apple is mango is here or not, so you can say this is a mango that belongs to in this. Okay, so this is well defined, so that I would say this is, yes, this is well defined. Okay, so the next one is that collection of intelligent people. So that's a bit tricky thing, that what actually means by intelligence. Okay, if someone asks you what about the intelligence means, so there is no definition of intelligent person. Either you could define it, but if you are defining intelligence by some criteria, but that will not be suitable for someone else. So you can't tell about that either Mohsin belongs to this collection, Mohsin does not belongs to this collection, and someone else like Imran belongs to the someone, and Michael belongs to this collection or not. So you are unable to tell about anyone that either that will belongs to there and that will not belongs to there. So that's not clear to us. So this is not well defined. Okay. So now the next one example is that here are the trees, and you have to tell either this is well defined or not. So this is not clear that which trees they are. Either they could be a like apple trees or banana trees or mango trees. Which trees? So this is not clear to us. So we cannot tell about that. Either the banana tree belongs to this collection or not, or apple tree belongs to this. So this is again not well defined. Okay, so this here is an other example that says that you have to tell about the collection of students at some school. So this is well defined because the students are really well defined to everyone, that you can tell about anyone in this world that that person is either belongs to this collection or not. So this is well defined. So that means I would say this, yes, this is well defined. So next one is the collection of chairs. So there here all types of chairs we have collected, and for every chair you can say this is there, and for every other thing other than chair you will say this not here. So that's mean, and this makes it as well a well defined. Okay. So I hope that you understood that what actually is well defined means. So in the next slide, now we are going to tell about the few mathematical sets that you know many of person knows. The first one is the natural, and that is in nature, and that starts the numbers, and they are the discrete one, and that starts from 1 and 2, 3, and so on. But in the advanced mathematics, someone asks this is a positive natural number, and from natural numbers they say that starts from 0, 1, and 2, and the old notation, this is the whole numbers actually. So that's up to you, that either you can say this is a whole number, or you could say this is a natural number and this is a positive natural number. So that's up to you. So similarly, the next one is then integers, and integers contains the positive and negative numbers. So there are infinite many mathematical sets that we could define. So that you will see many of the examples in the upcoming videos as well. Let's say I would say the name of that set, that is a Cantor set. So Cantor set is actually collection, and I will define in the next future videos. So please follow my channel and you will see these interesting sets. And the next one is the rational numbers and real numbers, and so on. And the last one I could say here, that is complex number, and that is a set of matrices, and what actually are the matrices and why we study them. So you could also see this in the future videos, and this is also about the complex number. But here in this video you could see that these are the some famous mathematical sets that we take into our consideration. So now we go to the next one, that is functions. What actually is the function? So function actually is a relationship. Okay, but what kind of relationship is this? This is a question. So, and about which, like about some persons, about, so this is a relationship between sets that we had defined already, that what actually are the sets. So this is a relationship between sets, and this is a particular relation, that every relation between any sets cannot be a function. So this is a particular relationship between sets. And what kind of relationship is this? So let's say that relation I define this R between two sets. Let's say this is a and the other one is B, and from A to B. If this is a relationship, then what condition should satisfy this relation to make it a function? The first one is that each element of A correspond, that is corresponding associated to some particular or a unique one. Someone say particular, or someone say this is a unique element of B. Okay. The second, what other condition should satisfy? So that again, what actually is, so I could translate this thing the some particular, so that can be defined in the next condition. I could say write it like no no two elements of B associated to some element of A. So this condition we are not going to discuss. Okay. So let's say that we first of all we define some look the some functions that are the relationship between the sets. So let me explain this by taking some examples from our daily life. The first one is that if I take the collection, let's say the collection is the students of undergraduate at LUMS. Okay, this is the name of the university that I am studying, from where I am doing the PhD. So this is the LUMS University. So that is a particular institute where we are taking the students of the class undergraduate. So this is a collection. So this is well defined, right? Because for every student, for every person, you could say that that either that will be a student of LUMS or not. So you could tell about this. This is well defined. So this is a set to us. The other thing that I could take, that is a real number. So this is well defined as well. Then what I define the relationship, and we look that that relationship is a function or not. So relationship is that from A to B, assign the weights. Okay. So we are going to assign the weights of each student uh, from the real number. So you can see that there will be no such student whose weight will not be assigned. So every student had some sort of weight, so that each of its element had associated with some of elements of B. But the next condition was that there will be no two numbers that will be associated to one of A. So that's clear to us that no one person could have a two weights. Like if there is a person something like Michael or John, and John couldn't have two weights like 48 and 45. So if someone else say you at the same time, that is not a difference, that it has a 45 kg or 48 kg weight. So you will not, because this is not possible. Okay, so this shows that all of the two conditions of the function satisfy. So this assigning the weights from the students and to real numbers, so this relationship is a function. Okay, so other relationship can also be defined in this way. So I believe that you now be very much clear about it that this is not all about writing f of x equals to x to be a function. This is all about the relationship between the two sets, and that collections could be anything. So here, assign the rule numbers. So if you assign the rule numbers to the students, then this is again a function. This rule is again a function. So I ask you, please try to find the more examples, such kind of daily life problems to, or examples, to find the more daily life examples. Okay. So this is somehow an assignment to you. So look, I have some. So let's see. Here we have some relationships between the two sets. One set is that contain the elements A, B, and C, and the other set has contained the elements 1, 2. Then their relationship is defined between them, and we have to verify, or we have to identify either that is a function or not a function. So here you can see that the first condition of the function is not satisfied, because we have said that each element of the first set should be associated to some element of the second set. So C is not associated to any of the set. So that's why that won't be a function. So the answer for this will be equal, will be what? That this is not a function. Okay. So next one is this one, and in which you can see that each the first condition is satisfied. Then what else the condition doesn't satisfy? So look, that the other condition was that the one of it couldn't be satisfied. Two of the second set shouldn't be go to the first one. So but this is true as well, that this is satisfied. So this is a function. So next one we see that here this is not a function, because both of the condition not satisfied. Which both condition? The first condition was that each of the first set should be associated to some of the second set. So C is not associated to any of the elements in 1, 2. And the second one was that the any of the two elements of the second couldn't be associated to one of the first. Like the one person couldn't have two weights. Like as we are saying, there was assigning the weights to the people as a function. Then there couldn't be same weights to the different weights to the same person. So this is not a function. So this is again not a function, and this is it a function? So let's see that each of a first element is associated and the two of it is not associated to one. So this is a function. And the last one is that each of the element is associated. So this is somehow this is known to be a constant function that you could see in the upcoming videos. So this is again a function. So next, we see a few of the examples of the mathematical functions that is very familiar. So there are many, and we will discuss them in our details in the upcoming videos. But here the first one is that f of x equals to x, or even f of x equals to some constant. So this is for each value of x we are getting the constant, and all these most of the cases of them are considered to be like this, from real to real. And there are some examples. So there is a trigonometric function, that is a sin x, cos x, and tan x. And there is a logarithm functions with base a. So we will see more examples and more details of this. So thank you for watching this video. Stay tuned with me to get more interesting videos, and please subscribe and like the videos. Thank you so much.